All right, so boys, we're going to calculate the efficiency of a system. So remember, efficiency is just a way of measuring how much energy do you put in and how much work do you get out. Okay, so it's just a way of comparing two things. All right, for this, we're going to be calculating efficiency. So all the notes should fit into this block. And here are some example questions that you're going to calculate on. You are allowed to use a calculator, and those questions will be coming up in this lesson, so you'll be able to pause the video and try and work them out yourselves to get a little practice to make sure you're learning this stuff. Okay, fantastic. So mechanical efficiency is another word for it. Efficiency is the percentage of work input that is turned into useful work output. All right, so let me break down what that means. So work input is the amount of energy you put in is turned into useful work output. Okay, so, and it's a percentage. That's quite nice. Okay, it might sound a bit confusing. You're like, I don't understand. But you guys actually do this all the time. When you work out the percentage of your marks, you're working out how much was the mark out of, how much did you get, what is that as a percentage. That's basically what we're going to be doing today. Okay, so I think the formula should come out now. This is the percentage of how much input energy is turned into output energy. Okay, so another way to say this, before I put the formula up, let me explain what I mean by percentage. It's a percentage of how much input energy is turned into output energy. So first off, you need to understand that a percentage is a fraction over 100. So it's something less than 100. Let's say 80 over 100 is 80%. So what I want you to understand is we're actually just working out fractions. We're working with fractions again. Don't get scared. It's going to be simple. You have a calculator. But it's the percentage of how much input, how much energy you put in is turned into output energy. So what you need to do is you need to understand, first off, that this will never happen. You'll never be able to put in 50 joules of energy and get out 50 joules of energy. Okay? That never happens because 50 over 50 would be 100% efficient. All right? And that does not happen. A system cannot be 100% efficient. The energy is always used and turned into something else. You always have to use more energy than you've got, okay? So let me explain what I mean, all right? So let's say I want to do 50 joules of work. So 50 joules of work is required for me to hit a hockey ball. All right, fantastic. I want to hit a hockey ball to my friend. He's standing about 10 meters away. I have to do 50 joules of work on that hockey ball to get it to my friend. But when I hit the hockey ball, I will actually be doing about 75 joules of work, okay? So that's the amount of work I put in. That's what I get out. What's happening to that extra 25 joules? Like if I'm putting 75 joules of energy into hitting that hockey ball, what's happening to that 25 that only 50 ends up going into the ball? Well, that 25 is turned into other forms of energy I don't want. The only energy I want is my ball moving. That is the energy I want. But sadly, when I hit that ball, you hear the noise of me hitting the ball, that conk, that is energy, that's sound energy. So some of those joules are going to sound energy. Some of that energy is actually causing vibrations in the stick that I feel when I hit that hockey ball. Some of it is being lost as the ball rolls over the grass. The friction of the grass slows it down, and it's absorbing some of that energy I put into the hockey ball. So a system cannot be 100% efficient. So the bigger number is always the amount of energy I put in. That's always at the bottom. And the smaller number is the amount of energy I get out, or the amount of work I get out, and that's at the top. And then we do our calculation. So here's how we work it out. Output energy, or the amount I got out of the system, is at the top. Input energy is the amount of energy I put in. And then we divide those two by each other, and we multiply by 100. So it's output divided by input times by 100. So O divided by, that's division sign, sorry, divided by input, I, multiply by 100. That's our formula, all right? I hope you know what it means and you're not just, oh, okay, that's a formula, let me try it out. Okay, so let's give it a shot. Because a pulley used at a work site is exposed to the weather, it is dirty and rusty. So it takes a force of 90 newtons, that's what's put in, to raise a 70 newton container of nails output. The nails are raised 8 meters to the second floor. What is the efficiency of the pulley system, or of the pulley? All right, pause the video, see if you can work it out. Remember, it is input divided by output times by 100. All right, the answer is coming in 3, 2, 1. The answer is 78%, okay? So what we did there was input was how much did we put in? Well, we put 90 newtons in. And we put that in over 8 meters, yes. But then what was our output? We divide by, let me put that in brackets, 70 newtons times by the 8 meters that we have to do it, because we have to apply it over 8 meters, times by 100, which will give us 78%. All right, that one may have been a bit tricky, may have gotten it wrong. No problem, let's try the next one, okay? A rusty pulley is used to lift a 2,450 Newton motorcycle onto a transport truck. What is the efficiency of the pulley if 3,500 newtons is used to lift the motorcycle 1.5 meters onto the truck? All right, remember, input divided by output times by 100. Your answer is 3, 2, 1, 70%. So it would be 3,500 divided by 2,450 multiplied by 100 should give us, oh, did you guys see my mistake? My mistake is this. I mixed those two up. Okay, the smaller number should be at the top, so it should be 2,450 divided by 3,500. All right, once I work that out and multiply by 100, I should get 70%. Okay, remember, this number at the top can never be bigger than the bottom number, okay? This number is always going to be smaller than this number. If it is the other way around, then you've made a mistake and you're going to get something bigger than 100%. And I just told you, a system can't be 100% efficient. It definitely can't be more than 100% efficient. Okay, cool. Here's an example. Ooh, I'm wondering if you guys can figure this one out. It's a tricky one. I put the answer up there. All right. So you may have gotten this one wrong because it is a trickier one. So if you looked at this picture, 200 newtons and it moved 80 centimeters. 600 newtons and it moved 20 centimeters. That's because the board, what you're using to lift it, actually bent. So what we need to do now is we need to work out the work done, input and output. So to work out the input, we take 200 times by 80, times by 0.8, sorry, because it's in centimeters, divided by input divided by output, which is 600 times by 0.2, and then times by 100, which should give us 75, if I'm not mistaken. All right, it's input divided by output and multiplied by 100. All right, should give you 75. Next one, let's give this one a shot. You can see it's centimeters. Again, it's moving. Try it. 3, 2, 1. Answer, 94% efficient. All right. So, boys, these last two were quite tricky, okay? That's all right. That's the more advanced ones. You'll try the practice questions below. They're a lot easier, okay? But I always try and push you a little further with what it's going to be when it gets a little harder, okay? So that's efficiency. And I think this is the more advanced maths we're going to get to. We might do mechanical advantage later, which will get trickier as well. But you guys can do this. Don't let the maths scare you. You've got a calculator. Just think it through. Maths is logical if you just take the time to figure it out. But you boys can do this. I know you can. Keep it up. All right. Cheers, boys. Good luck.